Hello,
Hi,
everyone.
how are you all doing?
Good, thank you.
Thanks, great.
Good.
How are you? Good to see you all.
And I'll just grab Aoife as well. Brilliant.
It's so great seeing you in person and not in emails right now.
Yeah, we can put some faces to names now, which is great. Okay, perfect. What I'll do is I'll hand over to Mariska. If I can ask, if you could all just pop around and just give yourselves a little bit of an introduction so we can know everyone's background and industry, and then we'll start working through some of the questions.
Yes, we actually made like a PowerPoint presentation with quick introductions. So let
Love
me
the
see
preparation.
if I can share that with you. Here you go. So these are the panelists today. We're going to do like a lightning round introduction. So I'll start with myself. So my name is Mariska. I work for Ultimaker. This is me in my natural habitat inside of the print room I have in the other room. I work with the Ultimaker Cura team, which means that we make a slicer that's used by millions of people all over the world that translates a 3D model into movements for a 3D printer. I also work with Ultimaker Digital Factory, which is software specifically for our Ultimaker printers, where you can start a print job from your home in your office or the other way around. And I'm also involved in helping with the development of the Cura Arachna engine, which is a really different way of slicing with variable line width, which I'd like to highlight maybe in a later point. My favorite tools for 3D printing are Tinkercad or Fusion, depends on how difficult the design is. I work a lot with Jira and Confluence because I work in software development and in Slack to talk with the different developers. So that's really quickly about me. Maybe Aoife can talk a little bit about herself.
Yeah, absolutely. So my name is Aoife Doyle and I'm based in Dublin in Ireland. So I work for iForm Advanced Manufacturing Research Centre. And my project is mainly based around developing a recommender system for this Renishaw 500M laser powder bed fusion printer. So the recommender system is more a framework, so it's not exclusively for this Renishaw printer, but that's where our development is going at the moment. So the idea behind this is that basically as the print is manufacturing in real time, the operator is getting alerts and information as to whether any process issues have cropped up and may get advice on how to fix the issues or potentially to abort the build if things go wrong. So you can see the Renishaw printer there in the top photograph. And then I have my go-to software is Renishaw Quant AM. That's kind of the where you choose your process parameters and slice your parts for the print. And then the iForm Data Hub recommender system. So that is going to be running as the build is manufacturing. And then at the moment, because it's in development, we then look at the CT scans and the mechanical performance of the parts coming off the build. So that we can relate that back to the behavior of the manufacturing environment, and then we can use that information to predict mechanical properties of the components. So yeah, just to quickly breeze into the tools. So basically, my favorite tools be any kind of digitization of the printer. So the sensors that we have at the moment, they look at the laser input energy and then the melt pool, infrared and optical emissions. But any kind of sensorization is good and helpful for our recommender system. And then programming, so RStudio and Python is kind of where we do our machine learning and deep learning kind of anomaly detection, so that we can look at any kind of weird or unusual patterns of behavior during the manufacturing process.
Very cool. Thank you so much, Aoife. Next up is Rachel.
Yeah, hi. I'm part of Henkel. I've been there for 20 years with a background in materials development. So I have been working as part of the product development team for the 3D printing for the last 5 years, and I develop materials that actually go into the 3D printer. So I'm a material developer. So my go-to software that I'm going to talk about today is Albert. So that helps us to keep agile and to for agile product development, and also for lab things and for doing printing, I like to use things like Autodesk NetFab is very good for if you have multiple printers, like if you use multiple printers like I do. And also good teamwork and good communication between the team also goes a long way as to help with the product development as well. So
Yes, thank you, Rachel. Teamwork is very important. We see, especially during working from home. Next up is Alyssa.
Yeah, thank you, Mariska. So, hi everyone, my name is Alyssa Berger. I'm heading the business development for Siemens Additive Manufacturing Network. I work for Siemens Digital Industries in their software business unit. The Siemens AIM network is a digital online collaboration platform that is connecting additive manufacturing part buyers, so R&D designers, engineers that have a need to get parts 3D printed with the additive manufacturing part suppliers. So this can be a company's internal production sites as well as their trusted external suppliers. And what you can see here, the upper picture is one of my natural habitats. That's actually at our Additive Manufacturing Experience Center in Erlangen, Germany, where we show the different software solutions that Siemens has available for our partners and customers. And our visitors can really try out the solutions, see how everything can work integrated and connected, also how you can automate your factory. And the lower picture shows a screenshot out of the application that I work for, the Siemens Additive Manufacturing Network, where you can see in this picture here our 3D viewer, where you have a nice visualization of your part that you want to get 3D printed. The system automatically calculates the bounding box and the geometries of the part, and we have some automated printability checks that are conducted in the system. Yeah, and besides that, of course, I'm also a fan of other additive manufacturing software. In general, I have a background in software development. I also have a background in the automotive industry. I worked for 6 years for Mercedes-Benz, where I was developing analytics solutions. And yeah, my favorite tools, I guess, for my day-to-day business are tools like Jira, Confluence, GitHub, also Monday.com for the project management, as well as I'm a big fan of face-to-face meetings. So at least we have all our cameras on. I really love that. And I'm so much looking forward when the pandemic is hopefully decreasing, or when we are over the pandemic and we can all meet face-to-face again.
I totally agree, Alyssa. Thank you so much. And finally, for the lightning round, it's Alice.
Hi, everyone. Hello.
Hi.
So I work at the Manufacturing Centre in the UK, which is also home to the National Centre for Additive Manufacturing. So part of our work is working with businesses and companies all over the country to help support them in their adoption of AM, but also working with industry themselves to help manufacture, help develop their manufacturing systems, help develop their tools and software. So unlike the rest of you, I am more of a software user than a software developer. I actually work in the design for additive manufacturing team. So 99% of my work is using these tools. So as a designer, my favorite tools are Rhino 3D, which is for surface modeling, using Grasshopper, which is a sort of algorithmic parametric add-on, which is the picture there on the bottom. Also for parametric CAD, we're using Siemens day in, day out as a sort of normal solid modeling CAD package. And then more recently for latticing or more complex geometries, we're using Entopology, which is implicit modeling. So using fields to just define your geometries. My favorite tools, I've listed there already. Grasshopper, I love it. It's basically programming, but with lots of visual buttons and nodes. So less typing and more connecting. And sub-D modeling. So I've got a little bit of a background in jewelry design, so I'm quite familiar with organic modeling and fluid modeling. I've seen, Mariska, on your Instagram that you've got a lot of jewelry and fun things that you've 3D printed, so maybe we'll have to connect after this and talk about that.
That would be so cool, Alice. I'm really excited. I also used to work with Grasshopper, and I really agree that it's such a visual tool, and it's so I think more people should use it because it's like a super cool way to model in 3D. So I have a short list of questions here. There's also a Q&A section where other people can ask questions that we're also going to address. So I want to start with the first question, which is what applications do you enable with your software? that are harder to accomplish with other kinds of software. Maybe Rachel, do you want to start?
Yeah, sure. As I said, my go-to software I'm going to talk about today is Albert. So we use Albert for our product development here in Henkel. So it's a state-of-the-art tool for agile product development. It's a cloud-based system, and it collects and clean and normalize data from every experiment, past and present, conducted at any Henkel facility across the globe. So basically, it allows us to track every part of the commercialization process, from a raw material to, in our case, to the finished part at batch level. It also allows, and this is how it's enabling our fast product development, it allows for increased collaboration between teams globally on different sites, and it's instant information exchange, and that's how it leads to quick product development. So for example, my working day could be over and I'm going home, but before I go home, I can put a work instruction task to my colleagues on the west coast of America. So when I come in the next morning, then I can look at my experiment, and it has been done and the data has been uploaded into Albert. So while my working day is finished, my project works can continue. So that's what's so good about Albert, is that it keeps driving the projects forward. So even though your working day is finished, your project can still continue. So we kind of call Albert our colleague that never sleeps, because somewhere in the world, Albert is always working and logging data all the time. So I think this is how it enables us to kind of keep connected and to keep the projects moving forward. And as we all know, in this industry, we have to keep agile. So that's how we use Albert for our product development.
So Alyssa, you also work Agile, right? Do you have an example of what kind of applications you enable?
Yeah, absolutely. So typical use cases for the Siemens additive manufacturing network would be companies that are looking for additive manufacturing workflow management solution, as well as especially for bigger companies, the AIM network provides you a mean to really build up your own company's AM ecosystem. So you can connect your engineering community, your designers, with your production sites, with your AM center of competences, and have all the collaboration streamlined via our platform product. That means that typical use cases would be, for example, it's very useful for your R&D prototyping in the field of additive. I also see customers and partners of us using this for customization, personalized products at scale, because when you have a different customization per part, at some point it gets really chaotic and messy if you don't have one central system and one platform in place that is managing all these incoming order requests from your different customers for you. And this is what the AIM network is really best built for, to handle all these increasing volumes of incoming order requests from your organization, streamline the AM workflows, the AM operations, all the way from customer inquiry over the part qualification to the order management, to the production planning and scheduling, to the production execution and the controlling conform reporting and shipping back of the successfully produced part to the customer. Other use cases would be, I see companies using this, for example, in their factories for on-demand manufacturing, to the different factories and locations for manufacturing aids, for jigs and fixtures, as well as for the spare parts business. It's actually a big use case, because with a solution like our AIM network, you can have your digital inventory of the 3D part files, and then you don't need to have these huge warehouses where you store the physical parts anymore, but you can really produce a spare part on demand at the regional location where needed, just by taking the digital file from the AIM network and getting it produced locally.
So Aoife, do you want to share an application for your software?
Yeah, absolutely. So I think there's kind of three situations where our recommender system could be applicable. So the first would be kind of in the development phase. So, you know, for example, your parameter choice is going to be based off of historical data of builds that have already been accumulated around the same material or the same part structure. So I kind of say to people, you know, it's kind of similar to a Netflix recommender, you know, if you're finished. Yeah, like finished a TV.
That's so cool.
Yeah, and it's like, what's the next thing you're going to watch kind of thing? And that's based off of like demographics. So what have other people watched? People who are similar to you, and based off what they like, Netflix is going to recommend something for you to watch next. So it's similar when you're designing a part, for example, it has all that data built up. So, you know, similar parts, you know, are going to have similar parameters that work for them. And that's how, you know, that those recommendations are going to be suggested to you before the build. And then, you know, aside from that, where I think the recommender system is very useful is that real-time element. So, you know, in a manufacturing setting, that, you know, the engineer can go off, the operator can go off, can go home, can leave the build running overnight. And any kind of process issue then is identified and sent straight to them on their phone. For example, they could check it, or their tablet, they can go on and see what kind of signals are coming from the different sensors. And then I suppose kind of the element that really ties it together is when the parts come off the build, and, you know, a lot of our research now is going into how they act, you know, in real life applications. So then we can combine that expertise as well to give a prediction based off of the signals that you're seeing coming in real time. So yeah, there's a lot of applications to it, and I think in Ireland as well, the biomedical industry is very you know, very prominent here. So we are working with medical device companies to actually kind of get this installed and get this running in a real industry environment.
That's so cool. So our printers only have like a webcam, and sometimes some people use spaghetti detection to see if there's spaghetti, because that's when an FFF print fails, mainly it's spaghetti. But this seems so much more cool and useful, especially being able to see it from a distance is super useful.
Yeah, I actually, when you sent that email about the spaghetti detection, I did look it up, and it is like, it's very much the same idea. It's the same kind of framework. And I know for like e-beam technology, there's something similar. It's called the RCAM layer cam, where it uses a camera installed to do the kind of anomaly detection that way using the camera for e-beam. So yeah, they're all kind of the same idea that, you know, you're trying to capture any kind of defective behavior before the build ends to kind of save time and save costs and everything. Yeah.
So Alice, you use a lot of kind of different kinds of software. Do you have like a favorite software for a very specific application that you cannot use other softwares for?
As I said, we use a lot of different tools. So at NCAM, we don't have just one type of technology. We've got polymer machines, we've got FFF, we've got SLA, we've got metal machines and SLM, we've got binding sinter machines. So we've got pretty much a machine for every occasion, and every single one of those machines has its own different sort of software sets, be it build processes or even build preparation software. Some of them don't even like the same slices. So we're working with lots of different tools every day. In terms of what Aoife was talking about earlier, in terms of parameter prediction, that's something that we're definitely interested in, always looking into, things like real-time monitoring software and tools that can help you predict the quality of your print while it's still printing, or better still, before you've even clicked the print button. So I won't go into specifics about tools, but we use a wide swathe of them. So Simufact and Hexagon and As2Print, all of these tools that are helpful in build prediction. But definitely something that would help select parameters is not something that we've used before, but would be massively helpful. For example, you can imagine every time we get a new machine, we have to now qualify all the new materials that we're building on it. Or even if we've got a really well-developed machine and we get a new material in, it's a very, very time-intensive and very expensive operation, just setting up the parameter set for your new material. So being able to reuse data from past prints for similar materials would be a great help in helping speed up that new parameter operation. So yeah, that's definitely something we're interested in. In terms of tools that I use that I don't think that there are any good equivalencies for at the moment, Entopology, which I mentioned earlier, is a really, really great one for latticing, for really quick iterations between different unit cells. So one of the advantages is you can set up your whole geometry and assign your different materials to different areas, and then really quickly iterate between different lattice unit cells, which is really great for speeding things up. If you do that in a parametric modeling, or if you do that in CAD, then latticing is at the moment very, very heavy duty. So using field-based modeling tools have been really great, and we do a lot of work within topology recently. Yeah.
That's super great. Personally, I'm really curious about how do you keep track of the different parameters. Sometimes I do tests with printed part quality as well, and then I have like a really long string of print jobs with like post-its on it with different settings I use for the different print jobs. Do you do something similar?
So that's not my explicit department. I don't work in that area, but I know that within our polymer team, they have their own internal infrastructure, which used to be, to my knowledge, an Excel database, which was a huge database of parameter sets. I believe we moved on to Minitab now, which is a databasing software. Similarly, the metals team have their own parameter sets saved for each of the different machines. As I said, I think it's Minitab that we're using at the moment, but I'm happy to stand corrected. So I will have to say I'm not 100% certain on how to answer that one, but it's definitely an important area for us, keeping track of parameters.
Yes, I can imagine. So for, I mentioned earlier, but in Ultimaker, we have been developing a different kind of slicer, which is called Cura Arachne Engine. And some of the developers call it that we pulled out the backbone of the current Cura slicer, which is used over Christmas. We had over 4 million slices in a single week, which is amazing. And instead of having like a normal pen, you only draw like straight lines. This one has you can imagine being a felt tip pen. So by applying different kinds of pressures, you can achieve different kinds of line width, which is really cool because you can make way more intricate prints with maybe very thin walls or very detailed letters or very detailed gears. And that's an application that we have not been seeing in other printers yet, which I think is pretty cool. So I mentioned I work with the software team, and we work in an agile way. And one of the key rules of agile is fail fast, learn fast. One of the ways that we do that is we try to release every 2 months a new version of Cura. And before we actually release it to the field, we release it to our community for the first 2 weeks to collect input during the beta period. To fix any big problems that we might have introduced by accident. Alyssa, do you maybe have an example of a fail fast, learn fast experience that you had at your job?
Yeah, so actually we also really live according to that principle. Our software development, we try to keep it as agile and flexible as possible. So we do have weekly sprint iterations where we develop new functionalities and features to the product. We also have weekly interactions with our key customers where we discuss with them, where we get feedback that help us to define our further development roadmap. And we also have dedicated development partners. So this is selected customers that are operating in a field that we want to further focus our future solution development to and to develop our product more to cover this new use case that this development partner is working in. And we actually have 2 weekly releases of new functionalities into production. Very often, if these new features or functionalities are not part of the core of the product, we only give access to these new modules to a dedicated set of customers, which are usually part of our development partnership group. And this way we have a dedicated set of customers that we have an active development partnership with that are kind of using these new modules carefully in production as a pre-release module. And when we see that this really works, then we release it to all our customers.
That's super cool. Oh my gosh. I'm so excited to learn about all of this. So Rachel, do you develop Albert in-house? Do you have similar experience?
Yes, Henkel is Albert is a Henkel software that we use to help our product development, as I'd said. And this question is perfect for product development because the fail fast, learn fast is as a mantra that we should live by for product development. As we know, fast ideation, iteration, it's very important, especially for agile product development, especially in the additive industry, because as we know, it's constantly changing all the time, and 1 week could not be the same as another, and never mind a month down the line. So Albert, it's a crucial tool for us for pivoting quickly. So AI software, it helps us to get valuable insights from development roadblocks in particular, and make informed adoptions then to move forward. So like kind of an example, we partner with some of the leading printer OEMs in the industry. So this allows us to have a close working relationship, and that kind of helps to create that fast learn, fail fast, learn fast. Sorry, when I tried to say it, mantra. So this ultimately results in solutions that are brought to market for the customer in astounding speed. So the fail fast, learn fast is something that we really do live by in Henkel and product development in particular.
That's really cool, Rachel. Aoife, you mentioned that part of the recommender software is also to help is to help improve print jobs over time. Do you also have a story where the software gets improved over time?
Yes, absolutely. So yeah, the first part of your comment there, I suppose, a big part of the reason that this software is being built in the first place is to help engineers developing new products to fail fast and learn fast. But yeah, in terms of the software, say, a large part of that is kind of pattern recognition and looking for atypical behavior versus typical behavior. So we had a run at one stage where we were trying to look to see if a hardware issue happened around the laser, a specific one. So it was laser defocusing. So that's where just the focal point changes. And this can happen naturally, but we actually did this ourselves. It was a designed laser defocus, and we wanted to see how that issue looked in terms of signals and how the recommender would go about it. So we originally had a set of rules looking to see the laser defocus, and we had these kind of hard-coded rules as to how much of an energy drop you would be expecting from the powder bed before a recommendation would appear. And as this build was in motion and this laser defocusing actually happened, we realized that the deviation of energy wasn't what we had expected, and so no recommendation came up. But we were able to see that very clearly from the signals in real time coming in, and we realized that our rules were just not sufficient in that case. So we would have to actually go to further anomaly detection algorithms, that the rules weren't good enough. So yeah, that was a learning experience for us.
That's such a cool example. Thank you so much. Alice, you don't work a lot with developing software yourself, but do you have maybe an example of a print job that required a lot of iterations? Because we see iterations everywhere in additive.
I don't work developing software myself, no, but I think one of the cool parts of my job and our role in the DFAM team is we do actually work with software developers to help them develop their software as well.
That's so cool.
Yes, so as Alyssa mentioned earlier, the sort of smaller groupings of pre-release testers, beta users and things like that, we often get pre-release versions of software to use to give our feedback and feedback into the development. So at the moment, we're actually working with Additive Flow, who I believe Matt Griffin has already brought up in the comments, Multimaker, who are an amazing new software developer who are basically working on a tool for multi-material optimization. So it's a closed loop part topology optimization program, which is capable of handling multiple lattices for unit cells or multiple different materials for multi-material printing as well. And we are currently working with them to develop their next version to the software. So basically this entails weekly meetings with them every single week to go through any problems that you found, any troubleshooting together. If there are things that we like from other software that potentially they could integrate. And I think what's great is because they're a small independent company, we've got a lot more access. So it's really nice to hear from Alyssa that even though they're such a huge company, they're still capable of doing that small scale fast iterative testing. So that's really good to hear. But yeah, I can't think of any other companies off the top of my head, but we're involved in the development cycle of a few of them.
But this is already really cool.
Yeah. And I think the most important thing is literally having that time to one-to-one actually discuss on a personal level rather than going through feedback in terms of like text box feedback on a website.
Yeah. So we collect a lot of our feedback is coming in via the GitHub, and we have like a dedicated person that's assisting everybody that provides feedback on the GitHub community. But we're also via support and via other ways we also receive feedback. But hearing these examples is just amazing to hear. So next up, Aoife, I was wondering, are there any tools that you're missing right now that you would like to hope to see in the future?
Yeah, well, I definitely think in terms of, making these recommender systems, I suppose where we're focused at the moment is actually on kind of defects like porosity that you can see from, the laser firing onto powder, like that behavior can show up in the sensors that we have. But say something like geometric distortion, for example, or, kind of what you were talking about earlier with the spaghetti detection, things like that. You really kind of need cameras to capture that shape or capture how, internal stresses can distort parts and things like that. So we don't have those installed currently in our product, but that would be, very exciting down the line and very important to have for a full kind of rounded recommender system.
So Rachel, do you have a wish list for the future, what you would like to see for tools?
Yeah, I mean, that's another good question, Mariska. I think for the industry as a whole, I think more kind of communication and information sharing, I think across the industry would be kind of good to kind of push additive just to where it needs to be. For example, we need to kind of maybe have a more holistic view of the entire digital workflow. And so say between standard agencies, testing agencies, perhaps raw material suppliers. And so if we could have information sharing between everyone, if there was a place where everybody could go to download information, I think that would really help the industry to be able to move forward. So I think kind of some kind of interconnectional tools in that regard. So I think that's something for the future that would be very good for the industry in general. So I think from my point of view, I think that's what I would like to see.
I think my answer would be quite similar.
Yeah.
I'm missing a lot of confidence. So we see in a lot of companies, there's like these star users of 3D printers that know everything about the settings and everything about the printers. But if you want to work together and collaborate, especially in architecture firms or designer firms, there's a big gap in confidence between people who work with the printers a lot and not so much. So for me, I would really like to see a way that we can bring back the confidence or like slowly ease people into 3D printing and getting them comfortable in a very gradual way. Do you see this threshold to enter as well, Alyssa?
Yeah, absolutely. That was actually one of the main reasons why we started to develop the Siemens AIM network, to build this platform where people can connect in an enterprise context and even beyond the borders of the company with external suppliers and partners. Our system really aims to also give an easy access to engineers who might be very experienced with maybe more traditional manufacturing technologies but might not have that much experience with additive manufacturing specifically yet. So if you enter the platform to get your 3D designs validated and to get them 3D printed as a test print, then it's basically the system guides you through the specifications, and it's enough to fill out the basic specifications and leave the details to your production site or to your AM expert on the other side. Or if you're a more experienced engineer, you can go to the advanced specification settings and really detail it all out and get it printed the way you want it. So this way, we allow people to use our platform that have different levels of expertise and still get exactly what they need. But talking about tools or things that I'm still missing and would like to see more in the future, and what I understand from this round today is that some of you are really working on these things, so that gets me really excited, is I'm very often looking for more advanced AM technology material advisor software, something that provides users more with a smart recommendation, also in an automated smart way. Okay, this could be the right technology material fit for this kind of part design, and that also more advanced part screening, part identification software that helps company to identify more parts that can be suited for 3D printing.
Yes, that would be amazing. So now we have a lot of engineers that look good in a suit, and we send them all over the world to help with part identification. But if there is a way to do it automatically, that would be so nice. So Alice, do you have a wish list of tools you would like to see in the future?
Yes, a very long list of things actually, but I think I'll start by saying I think the holy grail that we've all been discussed is this automated system of you upload your part and it tells me exactly how to print it or how not to print it and if it's viable and all of that. Which, as wonderful as it sounds like it would also take my job away from me and do what I do on a day-to-day basis. So a bit scary, but definitely something that we should all be working towards. At a smaller scale, sort of technology level, I think one of the things that you mentioned earlier, Mariska, in terms of advanced slicing is something that we're always looking into. So in FFF systems, planar slicing, I think, is becoming somewhat outdated. And so new slicing tools that are capable of doing non-planar slicing or multiple thickness slicing, or as you said, multiple bead widths or variable bead widths. There are a few tools at the moment that are being developed at very, very low levels, sort of academic levels, which are capable of manually defining all of your print paths, but actually seeing those scaled up into commercial software that allow you to do multi-axial printing or variable print heights and thicknesses. That would be really, really great. And also anything that cuts down any errors between the discretization of your perfect CAD between all the STLs and then the final print path. Anything that gets rid of the stuff in between, that would be excellent.
So, I agree.
Yeah, that's such a good list, Alice. Thank you so much for sharing. I'm gonna move over now to the Q&A session. On the right, there's a possibility for the audience to submit any questions. I'm just gonna take the top question right now, which is, how can we take our data, for example, for materials, and work with the equipment manufacturers to track the full digital thread?
Yeah, I can answer this one because in Henkel, as part of it, we kind of do a bit of this already because we work, as I said earlier, with our OEM printer partners. So basically, us as material developers using Albert, we can kind of already track all of the data that's in Albert, as I said, from raw material right to finished part. But also when we work with our OEM partners, we take work with them and take their workflow also as well on their printer, and we have the entire digital thread from beginning to end that can be tracked. It's also very important for things like, if you want, for digital manufacturing, for quality standards, for that type, it's very important for traceability. So I think we kind of do that already quite well in Henkel with for our materials development. So we can already track the full digital thread from beginning to end. So I think it's actually quite important, and it will be even more important going forward as additive gets more and more into the manufacturing space. I think it's going to be very important for standards and for quality to be able to track the full digital thread. And as I had mentioned earlier about the holistic view of the whole digital workflow, I think that's going to get more and more important going forward in the future. So
for standardization, it's super important to track where your parts are coming from and where they have been. Yeah, I totally agree. So I can also, if people want to answer their questions, shout now, or I'm just going to go to the next question, which is also fine. The next question is, what skills do you need to grow if people want to start in your field? I can start for myself. I'm part of a software development team. I did not study software development at all. I'm an industrial design engineer, and I just called Ultimaker saying like, hey, I really love your printers. Can I work for you? And I started at the bottom and I just climbed my way up. So I think the skill I would have liked to have before entering the field was knowing more about software development, about agile development and Scrum practices. But those are also skills that I collected over my working years. So if you can prove that you can grow a lot, that would also really help.
I think from my point of view, I think patience is a good skill as well, especially if you're getting into working with 3D printing, because sometimes I think, as Alice said it earlier, sometimes if you've got a new material to qualify, or if you've got a new printer, sometimes it can be kind of a bit tricky, and it doesn't always behave itself like straight away. So I think sometimes some patience as well can be a good skill, especially if you're coming into this industry. So I think that's pretty good, and also curiosity and enthusiasm, as well. I mean, good scientist. I mean, coming from, I suppose, the product development side of things, I think is kind of just to be a good scientist in general is a pretty good skill to have.
We often joke that the printers smell fear, so no brush speeds. You
Exactly.
need to take your time.
Or don't start to print on a Friday morning because because you just know that you're going to be there till like 6 or 7. You're not getting home for the weekends. So you get to learn all these things as you work.
Any other tips?
I suppose I could just add to that I, similar to yourself, Mariska, like I didn't train in, like software engineering or anything like that. I came from a biomedical engineering background, but kind of for my master's thesis was kind of heavily focused on kind of data analytics and things like that. So I think it's that kind of problem solving or kind of data analytics element that's helped me in this job for sure.
That's such a good comment.
Yeah, I don't have anything unique to add other than I think, Aoife, like you said, problem solving, and like Rachel, you said, learning the scientific method and expecting to fail. Just, it's okay to fail a few times, but make sure the next iteration is better than the first one.
Yeah, I agree to everything that has been said. I think it's a mix of engineering and software development skills. For me, it was actually the opposite than for you, Mariska. I studied IT, I studied software development and business, and I grew into the engineering field and into additive manufacturing. Well, I'm coming from a engineering family, so my father was an engineer, and I kind of grew up with it, but I never studied it. So I think it's good to start in either one or the other direction, or best is of course the both of it. But if you're motivated to learn and you're really eager and have a passion for these kind of topics, I think you can grow into it. You just need to apply good common sense, logic, thinking, and it's a super diverse field. And I think even though additive manufacturing is already there for a while, the full potential will only unfold in the next 5 to 10 years.
I think so too, yeah. So the next question is, what are some of the best practices for using the software, especially software files and data that you take from software package to software package? For example, in Cura, we have in Ultimaker, we have the digital library. So if you finish a print job, you can, if you use an Ultimaker printer, you can choose to save it to the digital library, and you can share the files inside of your digital library with others, and you can have others start a print on the different printers that are connected to it. Do you have any other examples of moving files from the different softwares in the suite?
Yeah, so at Siemens, I mean, we also offer a very comprehensive software solution, especially for enterprises that are dealing with a lot of data around the world. So here, at a certain scale, I would always advise to have a good central data management system in place. Like, for example, at Siemens, we have Teamcenter for all the manufacturing data, as well as, from my experience, what I see very often today at companies is they started with additive manufacturing and it really grew over the years, and a lot have really grown their center of competences into a company internal service provider for printing additive manufacturing parts. But then they use a lot of different softwares for the different process steps. At the end, it really helps to have this integrated into one workflow. So for example, with the AIM network, we really aim to integrate with different software. So Alice, you mentioned that you also work with Siemens NX, probably with Siemens NX AM. So for the CAM part, for the build preparation, we, for example, have a seamless data flow from AIM network to NX AM. So you do the order management and the production planning and scheduling in the AIM network, and then you can just go and directly open your prepared print job in NX AM for the whole build preparation without having to download files and then upload it into the next system. And I think in the future, the companies that will have these integrated workflows and that try to automate as much as possible of the workflow will be the ones that can really scale and will be successful in the long term.
Yeah, just to comment on top of that, we have only recently just started using Teamcenter and PLM within our own enterprise, but that's definitely something that we're trying to aim towards in the future, of having a one streamlined approach. It is slightly difficult for us, just because we use so many different tools, because we've got so many different machines and so many different software packages. But our aim in the future is, as you said, to have that all streamlined into one central database system. So yes, future aspiration for us, definitely.
Yeah, that's amazing.
Yeah. Wow. Well, that was a brilliant session. Thank you all so much for all of your input. That was so valuable. I could listen to you guys talking for a whole lot longer, but unfortunately we've reached our time limit on that. But yeah, thank you again so much. We'll be breaking out into a networking session now, but this marks the end of the technology EMEA block, which has been great. So yeah, thank you all very much. Look forward to keep connecting with you in the future.
Yes, me too. Thank you so much.
All right.
Bye.
Laura, bye.
Thank you very much. Bye.